Okay, so let us solve the expenditure minimization problem where utility function is, again, it's a function from R2 plus to R. Okay, and let us say the function is 2 root x plus y. Okay, and we want to solve the expenditure minimization problem. Okay, so what is the expenditure minimization problem? Recall that expenditure minimization problem is the following: that you minimize with respect to x and y, pxx plus pyy. Okay, so this is expenditure, px is given, py is given. You want to minimize this expenditure subject to the constraint that you want to attain some target level of satisfaction. Okay, let us say it is mu. Okay, so you want to attain some mu level of satisfaction. That's your target, and you want to do so at minimum possible cost given these prices. Okay, and solution to this problem is known as Hickson demand. So we'll see how to solve for Hickson demand. Okay, so what you're going to do is the following. You want to solve this problem, you first plot the constraint set. Okay, you first plot the constraint set. So what is the constraint set? Well, it is set of all xy pairs which satisfy this inequality. Okay, let's take mu to be positive. Okay, let's take mu to be positive, because if mu is 0 or negative, then the optimal choice is 0 0. I mean, it's a trivial problem. Okay, if mu is positive, then the problem becomes interesting. And basically, this is your level curve, that you want to get. So if you plot the indifference curve for mu level of satisfaction, you're going to get, this as the vertical intercept. Okay, and the horizontal intercept will be, when so mu square by 4, right? Mu square by 4. Okay, and when you plot the indifference curve, this is how it's going to look. And notice that if you figure out the marginal rate of substitution, the marginal rate of substitution in this case will be 1 upon root x. Okay, so what that means is that, as x gets closer to 0, the slope of the indifference curve, becomes infinity. Okay, so basically the indifference curve will be extremely steep over here, and then when it reaches the horizontal axis, it's going to look like this. Okay, so your constraint set will be this set. Okay, this is your constraint set. So you want to choose a point in this region that minimizes this expenditure. Okay, so what we can do is, just like the utility maximization problem, what we do is we try to climb to the highest possible indifference curve given the budget line. In the expenditure minimization problem, we try to come down as much as possible and figure out the lowest possible ISO expenditure curve, which is basically a level curve, corresponding to this, objective. Okay, so you figure out the lowest possible ISO expenditure curve that passes through this region. Okay, so notice that no matter what the prices are, this will never be the optimal choice. The reason is because no matter what the prices are, the ISO expenditure curve will always, part of the ISO expenditure curve will always be in this region. And in that case, you can always minimize, you can always reduce your expenditure further by moving to a point like this. Okay, this will never be the optimal choice, and the reason is just the same. It's the same kind of reasoning that you did in utility maximization problem. The reason is because if you see at this point, uh, if you are here, you would want to consume some amount of X. You wouldn't want to consume 0 units of X, okay? Because marginal utility associated with X is infinity, okay, and marginal utility associated with Y is finite, okay. So you wouldn't want to consume 0 units of X no matter what the case is. If the price, even if the price is very high, price of X is very high, you would still consume very little X, but you will consume positive amount of X. So this will never be the optimal choice. And geometrically, it is very clear that it is not possible to draw an ISO expenditure curve passing through this point that lies entirely below the indifference curve. That is not possible. Okay. So clearly, this point will never be the optimal choice. So there are two possibilities. One is that your ISO expenditure curve, the lowest possible ISO expenditure curve looks like this, in which case this is the optimal choice. Okay, the other possibility is that the lowest possible ISO expenditure curve looks like this, in which case this is the optimal choice. So there are only two possibilities for the optimal choice. One is this corner solution, and the other is this solution where marginal rate of substitution equals price ratio. Okay, these are the only two possibilities. Now we'll have to figure out under what conditions are we going to get this point as a solution, and under what condition are we going to get this point as a solution. Okay, so that is what we need to figure it out. Okay, and that would depend on whether the slope of the ISO expenditure curve is flat enough. If it is flat enough, then the optimal choice will be this point. However, if it is not flat enough, let us say if it is like this, then the optimal choice will be here. Okay, is this clear? Is that fine? So we just need to figure out exactly what is this condition, and how we're going to get that point. I mean, under what condition this will be the optimal choice, and under what condition this will be the optimal choice. So we just have to figure out how much is enough. What price ratio. For price ratio below certain threshold, this will be the optimal choice. For price ratio above that threshold, this will be the optimal choice. So we just have to figure out what is the threshold. Okay, so let's just do that. Okay,
Sir, can you repeat that
so
last point?
what I'm saying is that if the budget line is flat, then this will be the optimal choice. If it is steeper, then the optimal choice will not be this but this. So I just have to figure out the threshold, below which if the price ratio is below that threshold, then the optimal choice will be this, and if the price ratio is above that threshold, then the optimal choice will be this. So I just have to figure out where the threshold is. Is that clear? Is that
Yes.
fine? So let's just do it. Okay, so xh, yh, px, py, mu, okay, is equal to, okay, and in this case it's a unique solution, so I can use equal to sign, there's no problem. Okay, so is equal to in this point, what is this point? This point is mu square by 4 comma 0, and this is the case if at this point, the price ratio is less than the MRS, px by py is less than or equal to the MRS, which is 1 upon root x. And what is root x? Root x is root of this, right? Okay, so which is 2 by mu, right? Because 1 upon root x, 1 upon root of this is 2 by mu, right? Yes or no? So at this point, you figure out the slope of the indifference curve, which is 1 upon square root of mu square by 4, which is 2 by mu. Okay, if this slope px by py is actually less than 2 by mu, then you will choose this point. Okay, and if that is not the case, however, if px by py is greater than 2 by mu, then in that case you will choose this point. So how will you calculate this point? How do you figure out this point? At this point, 1 upon root x equals px by py, okay, which gives you what? X equals py by px square, right? Yes or no? Okay, and what is the y value, the corresponding y value? This is something that you're going to get by using the fact that this is on this indifference curve, this point is on this indifference curve. So I know that y must be equal to mu minus 2 root of this, which is mu minus 2 root x. So let's take the square root of this, which is py by px. Is that okay? Is this clear? So this is how you calculate the Hickson demand. Okay, let me tell you one more. There is another concept. I mean, you can actually plug these values here, and the value that you want to get is actually nothing but the optimal expenditure. The minimum expenditure which is needed if you want to attain mu level of satisfaction when these are the prices. Okay, so there is a name for such a function. You call it expenditure function. So what is expenditure function? Expenditure function is E px py mu. It is px into xh, basically the expenditure on the optimal choice. Okay, the cost minimizing choice or expenditure minimizing choice. So the expenditure on the cost minimizing choice is known as the expenditure function. Is that okay? And because this is a function of, this choice is a function of px py mu, and the other terms which are there in the expenditure are also px py, so the expenditure function is a function of px py and mu. And it is kind of obvious, right? I mean, the optimal expenditure will depend on the prices, and will also depend on your whatever your target level of satisfaction is. If your target is going to be higher, then obviously your expenditure will be higher. Okay, and if the prices are going to be higher, then expenditure is obviously not going to be lower. I mean, it will also be higher. Okay, so it depends on the prices and the target level of satisfaction, what your expenditure is going to be. So in this case, what is the expenditure function? It is so okay, let's see. So it is basically px mu square by 4 if px by py is less than or equal to 2 by mu. Okay, and it is py square by px plus py into mu minus 2py by px if px by py is greater than 2 by mu. Okay, so that's how you can write the expenditure. Is this clear?
Sir,
Yes.
sir, how are we getting this px by py is less than equal to 2 by mu? Can you explain that part, that how are we getting it 2 by mu?
Because MRS is 1 by root x, right? So what is the MRS at this point? How do you calculate the MRS at this point? This is mu square by 4. So plug mu square by 4 here, right? Because this is the value of x at this point. So what is the MRS at this point? It is 1 upon root of mu square by 4, which is 2 by mu, right? Is that okay? So you compare whether your budget line here is steeper than the indifference curve or flatter than the indifference curve. So if px by py is less than 2 by mu, which is the slope of the indifference curve at this point. So if px by py is less than 2 by mu, which is the slope of the indifference curve at this point, then you will choose this point. If px by py is greater than 2 by mu, which is the slope of the indifference curve at this point, then you will choose this point. Is that okay?
Yes, sir.
Okay. There is another way. Of course, this is the indifference curve approach. You can always convert this problem into one variable optimization problem and then do it. Okay, that is also another way in which you can actually solve the same problem. Okay, and of course you'll get the same answer. Provided you do it correctly. Obviously, no matter what method you use, you should get the correct answer. Provided you you use the method correctly.